This video covers language models that are capable of really long context lengths. I'll show you how to get good performance on these models and how to run inference on them. I'll start by giving you an overview of the Yi model, available in 6 billion and 34 billion sizes and capable of going up to 200,000 tokens in context length. I want to talk about the chat formats for that model and how to get good inference on it. I'll then touch a bit on long context models in general, because they're not all equal. Even if they say they have 100 or 200,000 context length, the question is, can they do Passkey retrieval and can they provide coherent responses? I'll explain why those two things are important to get good response results overall. Thirdly, I'll show some performance evals. I'm going to show you 107K context length in a summarization case using two A100s. And then I'm going to show you some inference using a one-click template from Runpod that I've developed. I'll just show 16K context there, which allows you to run on an A6000. I'll briefly then show you some function calling models I've developed if you want to use these long context models in conjunction with function calling. And lastly, I'll cover some resources around inference and also how to do some chat fine-tuning like I've done to develop the Yi chat supervised fine-tuning model. Bear with me now as I talk you through the Yi model, which is a very powerful model available in 6B and 34B. But of interest for this video, it's available in a format where it's been fine-tuned, or rather trained, with a 200,000 input context window. Now, importantly, this initial model was not released with a fully open license, but as of mid-November, the current model can be used for commercial use, although full details of that license have yet to emerge. Now, the base Yi model is not immediately compatible with a lot of the packages for doing inference. And so there's a llamified version, basically moving it into a Llama 2 style format that is on Hugging Face. Furthermore, this llamified version, even though it's more compatible, it's not a chat fine-tuned model. And so if you prompt the model, it will in many cases continue to blab on without stopping because it's not fine-tuned to have an end token and respond in a chat style format. For that reason, I've developed a series of chat fine-tuned models using open source data so that the model can still be used for commercial use. So this is Trellis, the 34B model, 200K context, llamified so it's compatible for inference with a lot of the packages, and then further fine-tuned in a chat format so that it will respond to your queries and then end once it's provided that answer. And this model is available in 34B and in 6B format for purchase. Now, even if a model says it can handle 200K context length, that doesn't necessarily mean that it's going to be a good model. There are two criteria that I like to think of for what I consider a good long context model. First of all, the model should be able to retrieve a passkey if you place it anywhere within that context length. If it's not able to retrieve the passkey, to me, that means it's not actually seeing all of the text input. And this is often what you see with Claude. It can handle a long context, but actually it's not able to retrieve a passkey from everywhere within the text, which makes me question whether any, or rather all, of the text is being processed. Second of all, even if a model can do passkey retrieval, it needs to be able to provide a coherent response. There are some models that are able to do passkey retrieval, often models that are not chat fine-tuned, and they can do passkey retrieval on long contexts, but they're not able to provide a coherent response, which is obviously needed if you want to use a long context model. So a good model should be able to retrieve a passkey from anywhere, and it should also be able to provide a coherent response. To illustrate this, I'm going to show you a version of the Yi model that is not chat fine-tuned. We'll take a look at passkey retrieval and also summarization. I'll compare that then with the chat fine-tuned model that I've developed, and then I'll also show you a quick example using Claude and its difficulty in doing passkey retrieval. I'm running in Jupyter Notebook now with an A100, and I'm going to run the LLM comparison notebook, which is available in the Inference repository available for purchase. I'll show you more about that at the end of this video. In this, we're going to compare two models, but first, let me just connect with my Hugging Face token. This will allow me access to gated models. The two models I'm going to compare are the Yi model, that's not chat fine-tuned, and then the Yi model that is chat fine-tuned. So let's accept those. Next, I'm going to do a series of installs. Notably, I have transformers here. I have bits and bytes because I'm going to use NF4 quantization to make the model a bit smaller to run on the A100. And I'm also going to install flash attention. We'll be using the V2 of flash attention, which includes flash encoding and flash decoding, which is very helpful for long context to improve speed. Okay, that will take a second to install. In the meantime, I'll move down here to loading. I'm going to load the two models, model A and B. This is the not chat fine-tuned. This will be chat fine-tuned. Notice that I am using quantization. I'm going to quantize with 4 bits for both models, so it's an apple-to-apples comparison. And I'll be using flash attention 2, so setting that to true here. So those models will then need to download and run. Note that I'm running the 6B models just because I want a fast demonstration here, but I do recommend using the 34B models. In fact, a quantized 34B is going to be better than using a 16-bit 6B model. So I would recommend for the best summaries or the best long context performance to use the NF4 quantization of the 34B Yi model. You can see that the model is currently downloading. There are 2 safe tensors files for each of these 6B models. That's a total of, I think, about 12 gigabytes each. And once they're loaded, we'll just print out the number of position embeddings. The maximum will be 200K because that's the context lengths it's been trained on. Now, just a note on setting up the tokenizer for Yi. There are 2 things you need to do differently than if you're used to loading Llama models. You need to install sentence piece, and that's a specific tokenizer package. And furthermore, when you load your tokenizer, you need to make sure that you set trust remote code equal to true. I've already done that for the second model, but I need to do it for both. So when I've done that, I'll be able to run the tokenizers. And here we're going to just print out what the beginning of sequence token is for model A, and we'll do the same for model B. Actually, the beginning of sequence token doesn't seem to be used in the Yi models. Only the end of sequence token is used at the end of the assistant response, and it's an end of text type token, not a /s like Llama. I want to move to doing a quick inference, just asking a simple question to list the planets in our solar system and have the model respond with a list of those planets. Notice here the prompt format. So the user is going to be human, :space, and then assistant. So it's quite a simple prompt format for the Yi model. This is specifically what I have fine-tuned the model on in developing my chat model. If you're going to operate the raw Yi model, I also recommend that you use this style. All right, the models have now been loaded. So the weights have been downloaded onto the server, and then the shards have been loaded onto the GPUs. You can see here the max position embeddings is 200K for the base model and the chat fine-tuned model. The tokenizers have been loaded. And here you can see that the end of text token is used to indicate the end of its output. And that will work well when it's a chat fine-tuned model, but not so well on the base model, as we'll see. Down here, we've run that simple question, list the planets in our solar system, and you'll see very clearly the difference between the base and the chat fine-tuned model. So here in the base model, we're asking to list the planets in the solar system, and the assistant responds, what is the name of the planet that is closest to the sun? And then it continues to alternate between human and assistant. And this is because it's not a chat fine-tuned model. Whereas if you go to the chat fine-tuned model, it says list the planets in the solar system, and the assistant says the planets are these 8 planets here, and it actually mentions 2 dwarf planets, that one of which Pluto used to be considered a planet. So that's correct, and it gives a clean stop as well. It doesn't blab on. So that illustrates the difference between the base model and the chat fine-tuned model in 6B, and the same happens for the 34B. Now that I've explained how the chat model compares to the base model, I want to show you Passkey Retrieval. So here I'm just going to run on the chat fine-tuned model, and I'm going to ask the model to respond only with the passkey contained within the text. And I'm going to help it a bit by saying the passkey is and letting it complete that sentence. There are about 12,000 tokens here passed in, and you can see right at the bottom that the passkey has successfully been retrieved. And as a reminder, this is the 6 billion Yi model. Now, I increased the number of tokens I was sending in, and I increased it all the way up to almost 200,000, and it's still able to retrieve the passkey, which is really remarkable in terms of performance. But this is an example of a model that does well on passkey retrieval, but still is challenged with having a good conversation. So let me show you what I mean when I ask it to summarize instead of finding a passkey. So here I'm going to ask the model to respond with a brief summary of the below text. And let's see what it comes up with. Again, I'm going to go for a similar number of tokens, about 12,000 tokens going in. And you'll see at the bottom here, there is actually a summary. And the summary is reasonably good. It's telling us it's a meeting about the Berkshire Hathaway's, it's about Berkshire Hathaway's annual meeting. So performance of the 6 billion model is actually reasonably good, around 12,000 tokens. And it actually continues to be okay as you go up towards about 20,000 tokens, although really I don't recommend using the model for much more than about 10 or 12,000 tokens. And let me just show you what performance starts to look like. I'm going to increase the number of characters of context I'm feeding in. So now I'll ask for a summary of 28,000 tokens. And let's have a look at the results here. So scrolling right down to the bottom. And yeah, so here the model is already kind of refusing to respond. And if I go up even further in length, which I can do. So let's increase again, maybe this time to 42,000 tokens. And let's see how the model responds. It'll take a little bit longer. But I'm just trying to show that even though the model can retrieve passkeys, that doesn't mean it's able to consistently provide a summary. Yeah, so here it is still having trouble. And what you'll also find, if you keep rerunning at different lengths, sometimes it will just start repeating text. Sometimes it will provide nonsensical text. So this just gives you an illustration of how passkey retrieval is not enough, but I think it is a sufficient condition. Now next, I'm going to show you an example using Claude, and here you'll find the opposite. So Claude is able to provide summaries, and I'm going to run this almost exact text through Claude in a moment with the similar length. So Claude can provide a coherent summary, but it's not able to do passkey retrieval, so it's kind of the opposite of the 6 billion model. So let's take a look at that. As you can see, Claude doesn't recognize that there's a passkey within the text. So what can happen with certain language models is they basically ignore parts of the input context or don't see it. And by doing this, it allows them to provide a consistent response by having an effective narrower window, but that means they're not able to process the full amount of text. Interestingly, the recently released OpenAI GPT-4 Turbo model, which goes above 100K in context, seems to be able to do passkey retrieval very well. And I'll show you an example of that when we run the Yi model on an API endpoint using Runpod later on in this video. Just to recap a little so far, there are models that can do passkey retrieval very well, like the 6 billion version of the Yi model, but they're not able to provide clean summaries or coherent text when you go beyond a certain length, probably around 20,000 tokens for the 6 billion model. There are also models that can provide coherent summaries, such as Claude, but are not able to do passkey retrieval, which means they aren't fully synthesizing the entire text. What you really want is a model that can both provide a coherent summary or response and is able to do passkey retrieval throughout the full context. Now, GPT-4, the new turbo model, is able to do this, and I'll show you a bit later on context up to 100,000 tokens. But what's interesting is the Yi 34 billion model is able to achieve both passkey retrieval all the way, like the 6P model, while at the same time providing coherent summaries at very long context. So let me show you an example of the Yi 34 billion model doing well on 107,000 tokens of context. Here we are with the exact same LLM performance comparison notebook, but this time I've loaded in the 34 billion model. It's the chat fine-tuned model, and so it responds coherently. And I'm going to scroll right down to the example I've run, which is asking the model for a summary of very many tokens. This is 107,000 tokens approximately. In fact, exactly, because that's what I've measured. And here we're running a request to respond with a brief summary of the text, respond with a brief summary of the above text. So let's scroll right down to the bottom of that text. and we can see how the model performs. So here, we'll see the end of that question. Let's see right here. Respond only with a brief summary of the above text, and then the assistant response. And here is what Yi 34B is saying. Berkshire Hathaway's 2023 meeting was held on May 6. The meeting was attended by thousands of shareholders. The meeting began with a summary of the first quarter earnings. Here are some other things that the meeting then discussed. And overall, the meeting provides shareholders with valuable insights into the company's operations and future plans. Now, I was able to run this on over 100K context on an A100, two A100 GPUs. I'm running in bits and bytes NF4 quantization. So this is the best quality quantization. It's not the fastest. It's slower than AWQ. It's slower than GPTQ, but it's better in quality than both of those. And you can see that I'm able to get quite a good summarization response. I suspect that if I increased up even higher towards the 200K limit, which might require up to 4 A100s, I probably would be able to get a good summary quality as well. But this is really impressive. It's an open source model that, with some further chat fine tuning, is capable of delivering a very good summary on a really, really long context length. The nice thing, if you're running this in quantized form with BNB NF4, you can get probably up to about maybe 40,000 tokens using an A100, but you do need probably 2 A100s if you want to get out to 100K in context length, and probably 3 or 4 probably A100s if you want to get all the way to 200K. Next up, I want to talk about inferencing these long context models, and I'll show you how to do so using Runpod. There's a link I'll put below to a server that, a template you can use for getting started with inference. It's called Long Context 200K Yi 34B chat. And we're going to run it on an A6000, which is quite a good value server. So I'm going to click here on deploy. Notice that I'm going to make some edits here. This model is a 34B model in full FP16, that's 16-bit format. It would take about 70 gigabytes. In bits and bytes NF4, it will take about half of that, so 35. An A6000 is 48 gigabytes, so 48 minus 35. There's just over about 10 gigabytes of space for the KV cache, which is needed for the sequence length. So I'm going to have to reduce the max input length here. I'm going to reduce it down to just 16,000. I'll put the max tokens at 17,000 to allow myself 1,000 output tokens. And the max batch prefill, I'll put at 16,000. You can also use AWQ. I've made that available as well for those who purchase this SFT model. It's faster, probably by 2x, although the quality is a little bit worse than using bits and bytes, which has got a better data format. So we'll set the overrides and get that pod running. Okay, here's the pod running. It has been fully loaded. You know that it's running when it defaults to the zeros as the host name. You'll see here that there's a pod ID. You'll need this for when you're sending curl requests. So I'm going to use that. And now I'm going to send curl requests to this server. It's running TGI, text generation inference. So when I send curl requests, I'll be getting right back responses from that server. For inferencing this model, I'm going to be using some scripts in Llama Server Setup, which is an inference repo that is available for purchase. It covers a number of things. It covers setting up an AWS server. It covers using Runpod. It covers function calling. And now it covers long context. It gives you a complete guide here that allows you to run with a chat interface, chat UI from Hugging Face, or just directly query with curl requests. So I've cloned that repository to my local, and we'll take a look at some of the scripts. The first script I want to look at is Passkey Retrieval. This one here simply takes the Berkshire text. It injects a passkey, and then it will ask the model to return the passkey. So we're going to test this out for 16,000 tokens, which is the maximum that we have defined on the server. So I'm just going to run passkey.sh, and that should send a request into the server. Here is the request. It's actually printed out the full prompt, which is probably a bit much because the prompt is quite long. And you can see it's responding with the passkey. So it's easily passing this test. The next test is summarization. So again, we're going to send in Berkshire. We'll send in about 16,000 tokens, and we'll ask it to respond with a brief summary of the text. So here I'll do summarize.sh, and it's with a Z. So sending in that query, and this is real time, so you can get a sense for how long it takes to get the response back on 16,000 tokens, knowing that it won't necessarily take all that much time longer per token generated with longer context, because TGI uses flash decoding. It's a way to make use of the full GPU, greatly increases speed if you're doing long context. Okay, so here is the response. The previous text is a transcript of the Berkshire Hathaway annual meeting, which took place on May 6. The meeting was attended by the shareholders. The meeting concluded a discussion of the company's investment strategy and its commitment. Okay, so you can see here we have a summary that's coherent, and this again is the 34B model. As I said, there is a commercial model from OpenAI, GPT-4, the turbo version. It is able to perform quite well on Passkey Retrieval. I've got a script in this repo as well that allows you to test. Here we can just do a quick test for an input of 60,000 tokens from OpenAI. So I can just quickly run that script to show you. OpenAI passkey.sh. So it's running a Passkey retrieval on 60,000 tokens. And I believe it won't have a problem. Here we go. And the content that it's responded with is indeed the passkey. So to sum up for a third time, it's helpful because there's so much involved here. There are limited number of models that are able to do passkey retrieval and provide good summaries. GPT-4 Turbo is one example. It can go around 100K in context. Yi 34B is another example. Even in quantized NF4 format, it works well at 107K of context. It probably works well at 200K of context, but you would need to be running about 4 A100s to get that kind of performance. What I just showed here was using an A6000. You can get good summarization on 16,000 tokens of context. If you're interested in a function calling version of the Yi model, I have got a chat fine-tuned version of the Yi model that is further fine-tuned for function calling. And you can find that those details on Hugging Face if you're interested in purchasing that model for functions. Zooming out now a little bit to talk about long context model resources, let me go through a few things that might be of use. I'll put links below to the raw base models for you to try out by yourself. If you're interested in the chat fine-tuned models, you can find them on Hugging Face by searching for Trellis Research and then looking for chat SFT along with the Yi 34B or 6B names. As I mentioned, function calling models are available. You can find them on trellis.com or via the links I'll put below. In order to develop the chat fine-tuning model, I went through a process of supervised fine-tuning using an OpenAssist dataset that I had modified for the Yi chat format. If you would like to chat fine-tune your own models, you can do so by purchasing the chat fine-tuning script, which is available on trellis.com. You can also just purchase the entire repository that covers a wide variety of training, supervised, unsupervised, direct preference optimization, quantization, and many more. Last off, I talked a bit today about inference and how to make the best choices if you're looking to set up an endpoint for long context. That is covered in the Llama server setup. Even though it's called Llama server setup, it covers inference for a wide variety of open source models, and it can help you out if you want to set up your own server on AWS, or, which I find quite handy, you just want to run quickly and cost effectively using a service like Runpod. In summary, it's now possible to get over 100K of context length with open source language models and the help of a little bit of chat fine-tuning. This is possible thanks to the Yi 6 billion and 34 billion models. From my testing, using the 6B models, you can get good Passkey retrieval, but you only get good coherent responses up to around 20,000 tokens. If you want to go higher to at least 100,000 tokens of context and probably more, maybe even 200,000, you should use the Yi 34B model. My recommendation if you're doing inference is to use it with bits and bytes NF4 quantization, or if you can and use more servers, more GPUs, you could run it in 16-bit precision. As I showed, you can run with 100K context using bits and bytes NF4 if you have 2 A100s. You can run with less context length, 16K or maybe even a bit more, using an A6000, which is quite good value, about 79 cents per hour. And you can do that on a service like Runpod. Let me know your questions on long context. It's been exciting for me to see it possible to get 100K of context. Up until now, it's been challenging to go much further than around 30K, especially for summarization and non-coding tasks. So let me know your questions below, and thanks for watching.